Assalamu alaikum friends, welcome to this MATLAB Simulink tutorial. Today I am going to teach you how to apply Wavelet Transform for power system fault identification and classification in MATLAB Simulink software. Friends, before going to implement Wavelet Transform for fault identification and classification, it is better to briefly discuss about the Wavelet Transform. As we know that a wavelet transform is a mathematical tool for analyzing the transient signals. In power system, a transient signal means a sudden momentary variation in current, voltage or frequency which may result due to power quality disturbances or faults in the system. These transients in power system are temporary overvoltages or overcurrents of short duration that last from few nanoseconds to few milliseconds. The wavelet transform approach can be used to identify and classify these transients or faults in the power system. It may be noted that a wavelet is a short duration oscillatory waveform with a zero average value which decays very fast to zero amplitude as shown here. As a mathematical tool, wavelets can be used to extract information from these transient signals by decomposing the signal into its component on different scales or frequency bands using the low-pass and high-pass filters as shown in the figure. The low-pass filter will result in approximation coefficients of the original signal, whereas the high-pass filter results in providing its detailed coefficients. Furthermore, a multi-stage filter bank is used to decompose the signal into various levels using the low-pass filter and high-pass filter as shown here. By using these detailed coefficients, the faults in power system can be identified and classified. Let's discuss its designing in MATLAB Simulink software. At the first stage, we need any power system on which we may apply fault and use wavelet transform to detect it. You may use any IEEE standard power system, or you may choose any power system from any research paper. For your convenience, I am considering the simple power system as shown here. This small power system consists of three-phase voltage source block working as generator, three-phase series RLC branch operating as transmission line, and three-phase series RLC load block to represent the load. For the modeling of this power system, I have already made the video with the title on how to design short transmission line in MATLAB Simulink software as shown here. Therefore, if you want to learn how this model is designed, you may go through this video for better understanding. It may be noted that for fault identification, we need all three-phase current measurements as well as neutral current measurement. Therefore, we need demultiplexer block to first separate all these three currents. For this purpose, go to Simulink library, take the demultiplexer block from here and bring it in the model. Connect this block here to measure the current. Double click on this block. Change the number of outputs from 2 to 3 in order to measure the three-phase currents. As we have to transfer these current measurements from Simulink to workspace in order to use it in wavelet transform, therefore go to Simulink library again. Take this 2 workspace block from here and bring it in the model. Connect this block with the first port. Double click on it and give it any name of your choice. Suppose I write here current 1 to represent the current in phase A. In the save format, click on array and press OK. Similarly, copy this block and paste it here. Connect this block with the second port of the demultiplexer. Double click on this block. Write here the name to current 2 to represent the current in phase B. Similarly, copy this block and paste it here. Connect this block with the second port of the demultiplexer. Double click on this block. Write here the name to current 3 to represent the current in phase C. Copy this scope and paste it here. Double click on this scope. Change the ports from 1 to 3 and press OK. Connect all these 3 ports of the scope with each phase currents as shown here. Now we need to measure the neutral current in order to distinguish between line to line fault and double line to ground fault. For this purpose, double click on this 3-phase source block. In the configuration section, click on YN and press OK. You can see here it shows the neutral port. Now we have to connect this neutral port with the ammeter to measure its current. For this purpose, go to Simulink library. Take this ammeter block from here and bring it in the model. Similarly, bring the ground block from here and bring it in the model. Now connect this neutral port with the ammeter. Similarly, connect the ammeter port with the ground. Copy this 2 workspace block from here and connect it with the ammeter port as shown here to measure and transfer the neutral current from Simulink to workspace. Double click on this block and write here current 4 to represent the neutral current. Similarly, connect the scope here if you want, otherwise it is not necessary. Now we need 3-phase fault block to apply fault in the power system. For this purpose, go to Simulink library again. You can see 3-phase fault block is available here. Take this block from here and bring it in the model. Connect all the 3 ports of this block with the 3 phases as shown here. Double click on this block. In the switching time, write here any time of your choice at which you want to apply the fault. Suppose we want to apply the fault at 0.05 seconds and remove the fault at 0.1 seconds. Therefore, write here 0.05 and here 0.1 seconds. Furthermore, you can see it gives you the choice to apply any type of fault, such as single line to ground fault in phase A, B or C. Similarly, you can apply the line to line fault by selecting any 2 phases such as phase A and phase B, or phase B and phase C, or phase A and phase C. Similarly, you can apply double line to ground fault by selecting any 2 phases and ground option. Friends, at this stage our model is completed. Now let's discuss how to apply wavelet transform to detect any type of fault. For this purpose, come to MATLAB screen again. For your convenience, I have already written small program to implement wavelet transform in our model. It may be noted that this program remains same for all types of models. You just have to change the name if you want. Let's discuss its all steps. It may be noted that the first and second command line consist of CLC and clear all command, which means it clears all the data in the command window as well as from the workspace before the start of the program. The third command line is used to open the Simulink model. You just have to write the name of the Simulink model as shown here. The fourth command line is used to simulate the Simulink model. You just have to write the name of the Simulink model as shown here. It may be noted that both names must be same. When the model is simulated, it will give the measurements of phase A, B, C and ground currents. As we have already given names of the current 1, current 2, current 3 and current 4 respectively. However, for better understanding, all these currents are again given proper names such as current A, current B, current C and current G to represent the current in phase A, phase B, phase C and ground respectively. Now this portion of the command line shows the application of wavelet transform on all these 3 phases and ground currents. The syntax to apply wavelet transform on any signal is shown here. In this syntax, waveDec represents the wavelet transform function to decompose the signal. X represents the signal. N shows the wavelet layer. By default, layer 1 is selected. W name represents the name of the wavelet type, such as Haar wavelet, double cheese wavelet, or any other wavelet. C is the output wavelet decomposition vector, and L is the number of coefficients by level. Now come to MATLAB program again. You can see here CA and LA represents the number of coefficients of phase A. Furthermore, we have used the double cheese 4 type wavelet. The next 3 lines are repeated to represent the coefficient of phase B, phase C and ground currents as shown here. When wavelet transform is applied on the signal and its number of coefficients are obtained, then another command is used to extract its detailed coefficient to know the further information. The syntax to obtain the detailed coefficient of any signal is shown here. In this syntax, DETCOEF represents the function which obtains the detailed coefficients of the signal. Now come to MATLAB program again. You can see here all these 4 lines are written to obtain the detailed coefficients of phase A, phase B, phase C and ground current. The last 4 lines are written to find the maximum value of the coefficients in each phase in order to distinguish between different types of faults. Friends, it may be noted that the main concept behind this strategy is that when fault is there in any phase, then that coefficient in that phase will have the very high magnitude and coefficients in other phases will have zero magnitude or very small magnitude. It means that if there is no fault in the power system, then coefficients in all phases will be zero or may have very small value. By this way, we can easily distinguish between different types of faults. Friends, at this stage, our model with wavelet transform implementation is completed. Now let's apply 3-phase to ground fault in the power system and measure the maximum value of all the coefficients. For this purpose, double click on this 3-phase fault block. You can see all the phases and grounds are selected, which means that in this arrangement 3-phase to ground fault will be applied in the power system. Now let's run the simulation by clicking on this play button. You can see when 3-phase to ground fault is applied, all phases as well as ground currents have very high magnitudes of the coefficients. Now save all these 4 values in a table as shown here. I will tell you later why we are doing this. Now come to model again. Double click on this 3-phase breaker block. Now suppose we want to apply the 3-phase fault but without ground. Therefore uncheck this ground option and press OK. Now run the program again by clicking on this play button. You can see when 3-phase fault is applied, all phases have very high magnitudes of the coefficient, whereas the magnitude of ground current coefficient is almost 0 or very low. Now again save all these 4 values in a table as shown here. Friends, repeat the same procedure and apply all types of fault, such as double line to ground fault between phase A and B, between phase A and C, between phase B and C. Similarly, apply all line to line faults between phase A and B, between phase A and C, between phase B and C. Similarly, apply single line to ground fault from phase A to ground, from phase B to ground, and from phase C to ground. After each simulation, save all these 4 values in a table for all above fault types as shown here. It may be noted that for all types of fault, coefficient values are extremely high, whereas when fault is not applied in any phase, then its value is very small or up to 103.9784 in our case. It means that suppose if we put the condition that in case of coefficient's value higher than 200, then fault is detected in that phase, otherwise no fault is detected and system is operating in normal mode. Now let's do it in the MATLAB program again to classify and distinguish between all types of faults. For your convenience, I have already written the basic MATLAB program consisting of if statements for all types of faults in order to distinguish between these faults. Let's run this program by clicking on this play button to check it for no fault condition. You can see this time it has provided the maximum coefficients values as well as has provided the type of the fault. As no fault is applied in the system, therefore it has correctly detected that there is no fault in the system. Let's check it for 3-phase to ground fault condition. For this purpose, go to model again, double click on this 3-phase breaker block and select all these 3-phase and ground options. Now come to MATLAB program again and run it by clicking on this play button. You can see it has successfully detected that power system has encountered the 3-phase to ground fault. You may check it for all types of fault by selecting or unchecking the options in the 3-phase breaker block to check the performance of this method. Friends, we have successfully implemented the Wavelet Transform for the fault identification and classification in the power system. As we know that each method has its own merits and demerits, therefore now let's discuss the limitation of this method. As you have noticed in the whole process that this Wavelet Transform based classification of faults in the power system depends upon the threshold value. The threshold value for this power system is chosen as 200. However, this value is not generalized and cannot be used for all types of power system. Or even this value cannot be used for the same power system with different voltages, power capacities, distance of the transmission line, or fault resistance. It means that for every new power system, this threshold value will be determined again in order to successfully detect and classify the different types of faults. Otherwise, it may not provide the correct results. Now, question may arise how to overcome this limitation. The answer to this question is that this limitation can be overcome by using the computational intelligence techniques such as artificial neural network and its types. These computational intelligence based techniques do not depend upon the threshold values and can detect and classify the faults without these threshold values. Friends, I will make another video very soon on the application of artificial neural network for the identification and classification of the faults in the power system. Friends, this model can be used to complete your bachelor degree FYP, or you can use this model with any other standard IEEE system to complete your master degree research or to complete one of the PhD research objective. For your convenience, I have uploaded the PDF as well as the Simulink model and MATLAB program in the form of link in the description section of this video. You may download it from there. That's all for today's tutorial. If you like it, then don't forget to like my video, subscribe my channel and share this with all your friends so that they may also get benefit from this video. Thank you very much.